Hi,
Hey,
Mala.
Ken.
How are you? Good to see you.
Oh, good to see you too. Thank you so much. Pleasure to have you present with us today.
And I imagine everybody else is happy that this is the last talk of the conference. So be all done after this.
Yes, it's been kind of a long day, but yes, we
Yeah.
were really looking forward to your session. And okay, so we missed that part. Um, your full name is Ken Cousin, and that
Yes.
has to be right. Yeah, yeah, perfect.
It's close enough.
Sorry.
Don't worry about it. I'm fine with it.
Okay. And let me quickly introduce Ken, though he doesn't need an introduction, a fellow Java champion, author of multiple books. I was trying to go through the list of the books that you've written, including the topics that you've written: Java, Kotlin, Mockito, um, talking about your boss, managing your boss. So there were so many of them: Java Rockstar, Gradle Rockstar. Ken, what's
It,
next?
it mostly means I'm old.
No, no.
I've just done a lot of stuff. So, well, next, I think I have to do this talk about testing in JUnit, Mockito, and AssertJ. So that's the immediate thing. Just keeping my eye on what's right in front of me.
Perfect. And everyone's watching. If you have any plans of doing some other things and you plan to watch a bit of the talk, that will not happen. Take it from me. I was attending Ken's talk at one of the events. I just forgot to leave the room because it was so amazing and engaging, and the examples were amazing. Ken, I almost missed my flight on that day, but
But
that was an amazing session.
but no pressure, right? Yeah.
Yeah.
I noticed, by the way, that you started with Venkat and I'm finishing. So I assume you're trying to separate us by as much as possible, keep us
No.
apart. We're trouble, you know.
No, it's like a square. We're meeting at the other end. So
Sure. Okay.
yeah. I'll be backstage if you want me to hop on and answer any ask you questions. I'll do that. Otherwise, if you are good to answer the questions yourself, I will just flash them on the screen.
Well, it's
Okay,
always
that's
nice
right.
to know you're there. Thank you. Okay, welcome everybody. I'm going to be talking about testing with Java, and I'm going to try to hit all three libraries. Now, the AssertJ one is just a syntactic sugar library that I'm going to add as we go along. But JUnit, I assume most people have used JUnit, so what I'm going to focus on there are some of the neat features that are in JUnit 5, some of the things that you may not have run into that often, but I do want to talk about that. And then the Mockito stuff, again, I'm going to focus on things that people don't tend to run into. There's a lot of misunderstanding about what a library like Mockito is for, and things like that can make it controversial. So I'm going to jump right in, and I've got some slides, but I have more code there. And as Mala was mentioning, there's my list of books and everything. So the only thing she didn't mention was Groovy. So I started off in a lot in the Groovy ecosystem, and I really like that. At any rate, there's all my contact information if you need it. There's my email address, homepage, blog. I still am occasionally on Twitter, although not much. I'm more on Mastodon these days. I have a free weekly newsletter called Tales from the Jar Side that comes out on Sundays. And then on Monday, I put a video version of it on my YouTube channel. And then I also have some technical talks as well, including playlists on Java testing topics. That QR code, by the way, goes directly to the YouTube channel, just letting you know. Okay, so let's just jump right in. JUnit, of course, is at junit.org, and that redirects to the latest version, JUnit 5. And they have a reference manual and the API Java docs directly linked from the homepage. If we need to go look at it, we will, but I'll stick with it. I should mention that if you go to the GitHub project, then the overall organization is called JUnit-team, and inside there is a starter project. And they have a starter project in whatever build tool you prefer, Gradle, Maven, Gradle with the Kotlin DSL versus the Groovy DSL. I think they've got a Basel one. They may even have an Ant one. So if you're trying to get started with it, that's always available. So this is kind of a list of all the major links, but most of those are just right off the home page. The only thing I really wanted to call your attention to, first of all, they have a Gitter group. This one listed down at the bottom. And Gitter, if you've never been there, is kind of like a Slack channel embedded in a browser. And that's where a lot of the JUnit team members hang out and answer questions. The other thing I want to point out is the first of the GitHub repositories I'm going to share with you is this one in my own GitHub account under my last name. It's called JUnit5_workshop. So first thing, though, I have to point out one of the interesting tidbits. They call this one JUnit Jupyter. And people wonder, wait, where did that come from? So there's JUnit Platform and Jupyter and Vintage. And they say that there's a separation between the platform and Jupyter, where platform is the underlying implementation model and Jupyter is more the programming extension model. I have to admit, I've been using this thing for years now. I still don't really understand the distinction between those. I'm a user. I'm not actually modifying JUnit as a library. So for me, all that really means is I have two sets of documentation that I need to look at to see what when release notes come out. The Vintage one, on the other hand, is interesting. When you add the Vintage dependency to your build file, that means JUnit 5 can execute all your old JUnit 4 and even, believe it or not, JUnit 3 tests as well. That means that you don't have to switch everything over right away, although, as I'll mention, IntellIJ has a function that will try to upgrade your JUnit 4 tests to JUnit 5. But you don't have to. You can just put in the Vintage engine, run all the old ones, and just gradually move up if you like to. Of course, the word Jupyter then gives me an opportunity to show a satellite photo from the Juno probe currently in orbit around Jupiter. I think it's about to do another para-Jove or whatever, close approach to Jupiter. Gotten some awesome pictures of Io from that. So why did they call it Jupiter? Well, two really silly reasons. One is that the word Jupiter also begins with JU, just like JUnit, and also Jupiter is the 5th planet from the sun. So there you go on that one as well. So it's JUnit 5. I don't know if they go to JUnit 6, if this will suddenly become Saturn. I have no idea. Okay, so a couple of things right off the bat. The life cycle annotations in JUnit are different now. So they used to say before and after, and before class and after class. Now they're before each and after each, and before all and after all. And I have to say those are a bit more intuitive, at least to my ear. That sounds pretty good. And the other thing to mention here is that with the before all and the after all, you now have to make those methods static in your class. If you annotate a test method with, what's not a test method, but it's a method in a test class. If you annotate it with before all or after all, those have to be static. Now, the before all makes a lot of sense because before all is executed before the test class is even instantiated. So there's not even an object available. After all, I suspect they made static also just to be consistent with that. Another neat thing is test names, and this is a nice thing because we get tired of looking at the long camel case stuff, and they have a display name annotation, and what's nice about it is that it supports all sorts of Unicode. So I took these right out of the manual, from the user manual for JUnit. You can use the guy flipping the table, you can use a munch screen emoji. Just to show you what this looks like, this is an example from that from my GitHub repository, but you can see I borrowed this example from the reference manual. And normally what I use it for is to put in like a sentence, you know, a test with display name containing spaces. But there's the guy flipping the table, there's the munch scream. If I was to put my cursor in the class somewhere and execute the keyboard shortcut just to see it, you see over here in the test results that you do in fact get the emoji, you do get the extra Unicode characters and everything. Looks pretty cool. So that's nice. The next one I want to go to is, by the way, you can actually get really slick with this thing. They have a couple built-in ones, like this idea, the display name generation says, let's replace all the underscores with a class. And I happen to have one of those too. Again, I kind of borrowed it from the docs here. So this one says display name generation, replace underscores. So it's going to take these underscores and replace the underscores with spaces. Same thing here. This is even a parameterized test, which I'm going to talk more about later, which is really nice. That's probably my favorite feature in JUnit 5. This one uses another one, indicative sentences generation, where the idea here is that this will start with the class name. A year is a leap year, and then put in the arrow and say if it is divisible by 4 but not by 100, etc. So let me go up to the top again, and I will execute this one. And this also shows another interesting feature of JUnit, which is the idea of nested classes. Now, the @nested annotation goes on a class. I don't think it's pronounced monk. It's munch. I mean, it's German, right? So, well, at any rate, somebody who speaks Deutsch better than I do, which is most everybody. I'd be interested in hearing their opinion. I'm sorry, I was reacting to a comment in the chat. I should have said something there. Anyway, this nested annotation goes on an inner class and allows you simply to organize your tests so that related ones all show up together. So there's nothing changing the behavior. All the tests are being executed, but they are listed in this combination like this. And you can see how this one has a year is a leap year. That's this one right here. A year is a leap year, arrow. If it is one of the following years, bang, bang, bang. And that's the parameterized down here. That's the parameterized test with the value source where they have these specific values in there with the ints. And now I can say we talked a bit about that too as well. Oh, I'm wrong. Yes, Munch was Norwegian. Munch, if you want to say, is Norwegian. And I certainly don't know how to speak Norwegian. So I've been to Oslo, but it doesn't mean I know anything about speaking the language. So thank you for that correction. Okay. Anyway, so that shows both the nested mechanism and a parameterized test and the naming convention, the way you can replace the underscores with descriptive sentences. Gradle would produce a nice test output. They wouldn't do much with the nesting, but it is, Munch, is it? Oh, okay. So again, I'm getting more advice in the chat on how to pronounce Edvard. I'll just call him Edvard, I suppose, at this point. So at any rate, that's what we have right here. Now, let me move on. So that's a series of them. And I'm assuming that font size is big enough that everybody can follow that. Let me know. Okay, so let's look at something else. The assertions class, everything's been moved from the assert class in JUnit 4 to assertions in JUnit 5. And there's all the standard ones that we've been using for years. Assert true and false, all the overloads of assert equals, assert null and not null, or same and not same for reference equality. And by the way, hi, Bill. So at any rate, the new ones, though, are really interesting. And some of them I use all the time. Assert, oh, thank you. I got some verification that the font's readable. Assert all is probably the one I use the most, even though many of these others are also based on the assert all mechanism. With assert all, then it takes as an argument 0 or more executables. And executables are basically runnables that can throw an exception. Now we'll get to that, and then there's assert throws and assert throws exactly. So this replaces the way we checked for exceptions in the JUnit 4 API. That was part of the @test annotation. Now it's a separate assertion. And you could say assert throws exception, and it'll catch everything that's a child of exception anywhere in the hierarchy. Assert throws exactly has to match the exact class of the exception. Assert does not throw is always interesting because that's just kind of documentation. That's saying, oh, I mean, if we threw an exception, the test would normally fail, but assert does not throw is basically telling the user, hey, you might have expected an exception here, but you don't get one. And I often use that when I'm doing something like dividing floating point values. And because if you divide integers by 0, you get an arithmetic exception. But if you divide floating point values by 0.0, you get infinity. You don't get an exception at all. And that's according to the IEEE 754 spec. It's the right behavior, but again, it surprises people. So I like to put in an assert does not throw, for example. Assert timeout preemptively are also awesome. With assert timeout, you basically say, okay, run this to completion, but if we exceed a certain amount of time, let me know how much we missed by. Whereas assert timeout preemptively runs the test in a separate thread, and if we exceed the amount of time we specify, it kills that thread. So if we say, oh yeah, assert timeout within 100 milliseconds, then we're going to run however long we run it. It'll say you missed by this much. Whereas assert timeout preemptively, it'll say after 100 milliseconds, it'll just kill it and say you failed. Very nice. But all of these take an expected and an actual. And this is the first thing I want to show you that's really kind of interesting here, kind of different. One of the things JUnit does is it allows you to put an error message of your own as the last argument in each assertion, unlike JUnit 4, where it was the first argument. Now it's the last one. But it's overloaded not just to take a string, but also a string supplier. And what that leads to is the following. Here, my lazy error messages test. So say I have a method called create error message. I'm just going to print that I'm there, and then I'm going to return a string. And I do the same thing for logging. In this particular test, when I log something like this, you're going to see that that method is going to get called even though I'm at a log level which will not show a find message. So it's a waste of time. I'm creating the message even though I'm not using it. Likewise here, this assertion is true. That's going to pass. Why bother creating an error message? See, again, that's just creating the message and just pointing out they're there. So if I run this one, you will see that, in fact, I wrote the log message here and the error message there. They both occurred because it didn't know not to. But in JUnit 5, they've overloaded all of those, all the assertion methods so that the second argument can be a string supplier instead of a string. And the cute part of that is that means you just take what you were going to do before, put parentheses arrow to the left of it, and now this is only evaluated if the test fails. Now in regular Java 8 and above, frankly, they've also overloaded all those extra logging methods to take a supplier, and this says this is only constructed if the logging level is such that the message will actually be logged. So if I run this one, you'll see I don't get any output at all, because now the logging is lazy, which, okay, that's Java. But this, and this is the same thing with the method reference, these don't get invoked because the test passed. Now, that's not happening by magic. If you dug into the assert true method, and I'm just using the keyboard shortcut for IntellIJ, that it takes a supplier, and I dig into that one, and right here is where the magic is happening. It's saying if that condition is not true, then go evaluate the get method on the supplier and go ahead and print up a failure message. But otherwise, it doesn't happen. And that's a really neat usage of this stuff. Now, in this case, there's no real gain here. I'm returning a constant. But if my error message involved reading files or going over the network or creating some complex object, this is a trivial way to avoid doing it unless it's necessary. So I like that. That's a neat little feature of JUnit 5. Now, I mentioned executable, and executable is one of the functional interfaces that JUnit created itself. They established it executable. And if you look at the docs for executable, it's the same as runnable. The only difference is that the method involved, the execute method, throws throwable. It's declared to throw an exception. This is important because, as you're no doubt aware by this point, when you use lambdas, they just don't play nicely with exception handling. It's really awkward. Nobody wants to embed a try-catch block inside a lambda. Then they become very difficult to read. You sometimes make a method reference and delegate to it. The point here, however, is if you declare that you can throw any kind of exception, who's got to catch that exception? Well, it's the framework. JUnit's catching it. It doesn't change our coding at all. And yet the framework will catch the exception and deal with it. Now, I call this sometimes a throwing runnable. That's really what it is. And the reason I did that is because there's two other classes in the JUnit API that we don't tend to run into. One's called throwing consumer, and one's called throwing supplier, and they are exactly what you expect. A consumer in Java, it takes a single argument and returns void. This is the same thing, but throws an exception. Throwing supplier takes no arguments and returns an object and potentially throws an exception. Now, I made a whole video about this on my Tales from the Jar Side YouTube channel. If you're interested, it's called Mastering JUnit 5 Functional Interfaces. But what I mostly care about is the executable one. These others don't come up as often. They can come up occasionally, but executables are everywhere, and assert alls are among my favorite conditions in all these things. So now I'm going to go to this parameterized test here, because that's where I really want to focus. I think I have that soon. I'll come back to the slides here. The idea of the parameterized test, I'm going to do an assert all in there. I'll come back to that comment. So what's a parameterized test? Well, parameterized test allows you to run the same test over and over with different data. So with a test, you also have to specify a source of data. And there's sources like, actually, let me skip forward in the slides here. It's, value source is explicitly listing a set of primitives. An enum source would be all the values in an enum, although you could filter by regex. Method source is you invoke a method and it tells you what you're going to run. CVS source is if you're going to a drugstore in order to pick up your I'm sorry, that was really bad, wasn't it? I shouldn't have. Hang on, I've got something for that. Yeah, okay. I mean, that's an American thing, but what the heck? Okay, so CSV source, obviously, comma separated values. And I also, you have a CSV file source where the comma separated values are inside a, in between the individual elements, where they're in a file, rather. And then the argument source. Now, somebody, Simon, hi Simon, good to see you, mentioned AssertJ soft assertions, and we do have those too. But honestly, I think the syntax is cleaner with the assert all and JUnit, so I tend to use them there, but it is available. At any rate, let me go back to the code here now. This is a parameterized test to check that a number is prime. I just made some isPrime method, and I'm going to assert that that's prime. My value source is a collection of integers. And if you look at the different possibilities here, there's ints, bytes, shorts, longs, floats, doubles, chars. So all the primitives, I want booleans too. And then strings, which, okay, that makes sense. And then an array of classes, which, okay, I don't really have a use case for that, but it'll work. And the best part about this is that when I run it, you get an individual test for each one, which is really nice. I also put in the composite ones, and then here's a method source where you delegate to a method. Now, the method requirements are the method cannot take any arguments because there's no way to indicate that in here. It has to be a static, like we'd normally call it a factory method, and it returns something that Java knows how to iterate over, streams, arrays, iterables, iterators, something like that, and then it'll work. So I'm saying call this method, get me back numbers up to 100, and then run them each through here, and you see that I got them all. Now that one is kind of contrived, especially because you can see I'm using the same method to find them as I am to test them, so that's not good. So let me show you a different example. Here I have an example that's a Spring Boot application and I like using Spring and Spring Boot because they have JUnit 5 and AssertJ and Mockito all built right into the platform. So I could use any of them. So what I'm doing here is I'm going to access a site called JSON Placeholder, which is a publicly available RESTful web service. And it's easy to access, and it's full of testing data, which you can modify, and it will just reset in between each call. So it's great for demonstrations. So this is what they call an HTTP Exchange interface in Spring Boot, where I can do get requests and post requests and put and delete requests, all of these different features. I have to declare a bean, like, let's see, this one down here. Well, that's a complicated one. I have a simpler one. But if you just use these couple of lines, you could set up a web client builder and then create a proxy around it, generate all that. That's all boilerplate, believe it or not. But here's the test. This is the part I wanted to show you. So let me use my keyboard shortcut to bring up the test here. And I can get all the posts, but here I wanted to get all the posts by ID from 0 to 100, or 1 to 100 rather, because I know there's 100 of them. It's in the documentation. So I'll call get and verify that the optional that comes back is present and it's got the right ID rather. And if I execute this, it's calling this get indices method to get my range of values from 1 to 100. Now the downside, as you can see, is I've got to wait for all of them to execute. And that brings me to another neat feature of JUnit 5, which is if you put in a file in your class path called junit-platform.properties, you can make the tests run in parallel. So this is still considered somewhat experimental, but it is, I put the link in there to the actual part of the user manual. If I enable the parallel tests and make the default mode concurrent and run the tests again, here, let me make this bigger so you'll see it happen. Then you see they're all coming out of order. They're all running basically more or less simultaneously. I probably should have printed out which thread I was on too. But again, I don't have that many that it takes that long, but I now ran them all in parallel. And in fact, it'll run all my tests in parallel based on that. So that's, again, a neat little feature that a lot of people are not necessarily aware of in JUnit. Now, let me talk about this. I did an assert true and an assert equals, and those really should be separate. Like if the value is not present, I don't want to call get on it. So this one, if the assert true fails, this one never gets executed, and that's normal. But if I had, actually, let me go back to this one here. Here, what I have is a test where I'm going to do let's actually go to the CSV. Actually, this is the method source. I'll go to the CSV file source. Okay, so let me explain the CSV file. Here is a CSV file. I've got a plugin in IntellIJ that's rendering this this CSV file as straight text. If I hit the text part, you'll see it's just ISBN, title, author, publication date, and I just put in the books there. And by the way, notice we got a line up here, which is headers. So now if I go back to the test, you'll see that I say this is a parameterized test with a CSV file, and there I'm pointing to that file. That is in my source main resources folder or source test resources. That would work too. Skip the first line, and I didn't have to say the delimiter. The comma is a default delimiter, but you can change it if you want. So what it does is it reads all the lines in that file and does a type conversion here to convert the string to a local date as long as it's in ISO 8601 standard form, which it does. And now I want to do all of these assertions. See, this is an assert all, which takes as an argument executable ... the vararg list of executables. So what assert all does is it will guarantee that all of these will run even if one or more fail. So I can run this and they will all get checked here. Now, I don't have this one running in parallel, but they are working. So at any rate, this is a neat use for assert all. Now, I think one of the people, I think it was Marit, mentioned the AI assistant in IntellIJ. I have both the AI assistant enabled and I have GitHub Copilot. I have both of those in there. And what I often do with the AI assistant is, like you see, I've modified my commit messages. So over here, I've made some changes already. And if I select all those and hit the AI assistant, it'll generate a new commit message for me. And I love this because I'm terrible at writing commit messages. You know, I get the one-liner and then it skips the space and it says everything that it changed, and I could just commit and push that to the repository, and that works. And I always used to do Git stuff from the command line. I never used to use the IDE, and now I've changed all that because this is so convenient. The other thing I was going to mention, though, is I have GitHub Copilot. So if I had written like 4 or 5 separate asserts, or say I had just written these things separately, if I'd gone assert equals for, or assert, I'll just do assert not nulls, right? Assert not null for the ISBN and the title and the, see how it's suggesting it? And then I go, you know what? Why am I doing those? Like here, if the ISBN turns out to be null, these fail, these don't even run. Well, I'll just go assert all, open paren, and then Copilot will go, oh, I guess you mean that, don't you? And oftentimes that is in fact exactly what I'd written below it. Now this one, it just reproduced more or less what I had here. And that's exactly what I use all the time. So the assert all becomes much more convenient now than it used to be because I don't have to write all these executables. It will be generated from my code. So that's really, really nice. Anyway, that's parameterized tests, and that's the file sources and all kinds of stuff like that. Okay. Oh, and here I mentioned the business about running those tests in parallel. This is the GitHub repository I was using to show that example. So that'll all be in the slides, which I'll make available somehow. I'll talk to the people at JetBrains how they want to collect it and maybe share out a link or something, put it in the description. One other thing I want to mention that is something a lot of people are also not aware of in JUnit, and it's the test instance lifecycle. The neat thing about the test instance lifecycle is in JUnit 5, you have the same default that you had in JUnit 4, which means every test instantiates the test class before it runs. So the actual test class gets reinstantiated in between the tests, and that reinitializes all the attributes and everything. Sometimes you don't want that behavior, or you don't need that behavior. If you set the test instance lifecycle to per class instead of per method, then they only instantiate the test class once. And by the way, then before all and after all can be in methods that are no longer static. They can actually be in actual instance methods if you want it. And it's just easy enough to switch. And I often do this in Spring, because in Spring, those test classes are singletons anyway. They're managed beans. So by default, they're singletons. And it's just a neat little feature to see there. Okay, I've got extra slides in here, but I'm going to skip on to Mockito now. Now, one last thing here is that JUnit 5 has its extensions capability, and people can make their own extensions. And the extension that's used inside Spring applications is the Spring extension, although I don't know if it's called Spring extension anymore. I think it may have some extra terms in it. But that's already built into Spring's test context. When we talk about Mockito, there's a Mockito extension as well. So let me talk about Mockito. Did I miss another rim shot? I don't know. I did one anyway, so I got that ready if we need it. All right, now here's the issue with Mockito. A lot of people just react negatively to the idea of mocks and stubs and maybe even spies, although there's not much to dislike about spies. And a lot of that negative reaction comes from a misuse or a misunderstanding of what they're for. So what I want to talk to you about is what they're really for, because the documentation for Mockito does not do a good job of explaining why to use it. It does a very good job of explaining how to use it, showing you what the methods do and what the arguments are and where they come up. But it doesn't really motivate why you would want a tool like Mockito in the first place. And people will say things like, no, don't use mocks, do an integration test, do a full functional test, because, you know, we get all these cliches of people doing unit tests, and the unit tests all pass, but the integration test fails. Well, here's my first point. Nobody in Mockito ever said, don't do an integration test. Of course, you're going to do an integration test and a functional test. Here's the issue. I think of it this way. Say I drive my car to the store or something like that. That is an integration test. Actually, that's a full functional test of my car in production, no less. And if I got there, it passed. And we're happy. I don't need unit tests for that. But if the car breaks down, I wind up on the side of the road, I have to get towed to a mechanic somewhere, then the mechanic has to figure out where the problem is. And the way they're going to do that is they're going to isolate each individual system. Is it the electrical system? Is it the transmission? Is it the engine? Is it you're just out of gas? I mean, it could be anything. And they need to test each individual system in isolation to narrow down where the problem is. That's what mocks are for. Mocks allow you to narrow down where problems are in your system. We just always think in terms of coming up with unit tests first and then building up to integration tests, but there's no reason you couldn't think of them in execution form in the other way. Yeah, okay, if it all works, then I don't need all those unit tests, right? Well, as soon as things start breaking, then they help me narrow down the problem. Okay, so there's Mockito, and oh yeah, I had to do this. I'm sorry. I apologize. But that's whenever I think of mocking classes, I can't help think about that. Incidentally, if you want it, I found on YouTube, there's a 10-hour version of that going on and on for 10 solid hours. Can you imagine? Yeah, let's move on. Oops, I tried to move on. There we go. Okay, this was the book, and the only reason I'm putting this slide in here is this is the GitHub repository I'm going to show you now. So this one's called Mockito book because it made the repository before I knew the name of the book at any rate. Let's move on. Now, there's a lot of documentation and Java docs and all that other stuff. And there's supposedly a mailing list, but it's got to be the lowest volume mailing list I've ever seen. I mean, there's hardly any activity at all for months on that thing. So I don't know where the actual core team members are hanging out, but it's probably not there. Okay, now let me explain a usage of Mockito. And for Mockito, I need a class to test, and that class needs a dependency. So there's a website out there called People in Space, that is at opennotify.org, and it's a RESTful web service that gives you a JSON JavaScript object notation listing of the astronauts currently in orbit. It's updated pretty much daily. It's a labor of love by the developer. It's free. It doesn't require a key, doesn't require you to register, anything like that. Of course, it only supports GET requests. Here's a sample from a while ago, back when there were still astronauts on the Chinese space station as well. This is what the JSON data looks like that's coming back. Okay, so there's a people collection, which has name and craft combinations. And then we have a message of success. Is it real data? Yes, it is, in fact, real data. I think it's updated daily. I don't know how often he updates it, but it's roughly daily. And then there's a number here to say how many. Okay. What I want is not just that list. I want to know how many astronauts are aboard each craft. That's what I want to know. So this means I'm going to have two stages to this. One is I'm going to actually call the RESTful web service, which will return that JSON data, and then I could map it to Java records. That's what I normally do now. And records are perfect for that sort of thing. And then to get the answer I want, I can group those records. I can group the instances together by spacecraft. So I can find out there are X number of astronauts aboard the ISS. There are so many aboard whatever ship is up there. And the ultimate return type will be a map of string. That'll be the craft name. And then this will be the number. So here is what the output would look like, something like this. And was that? Oh, something different. Okay, I was just glancing at the comments. All right, so let me start with a simple interface, which I'll call a gateway. A gateway is a design pattern that generally wraps network access. And I'm going to have a get response method that's going to return an item of type T, whatever it happens to be. And here is my Astro gateway, and the Astro response will be a record that maps to that big structure. And inside an Astro response is going to be an assignment. That's what I'm going to call my combination of name and craft. So there's the URL, and there are many ways to implement this. Now, the one I'm not showing here was using retrofit. I have an implementation that uses the Java HTTP client that was added in Java 11. For example, some people prefer, if you're a Kotlin person, you probably like to use KTOR. KTOR is an excellent client as well. Or there's also the Apache HTTP client. There are tons of open source, freely available networking clients you could use to access RESTful web services. So this is going to get that response and return it. Give me back the overall big object that has the little objects in it, unless there's something that goes wrong, at which point I'm going to wrap whatever the exception was in a runtime exception and rethrow it. Okay. Now, that was the Astro gateway. Now I want to talk about the Astro service, which is going to take that response and then convert it to what we want. So the Astro service will have a gateway in it. I mean, if this is Spring, it's an auto wire. Otherwise, we plug it in. And this is going to say, okay, let's get the response out of there and do your group by operation, which is in some private method inside there. This is where you start to need Mockito, because the success of this service, and in fact, this group by method, depends on the behavior of the gateway. And I don't want a failure in the gateway to make this fail as well. I want to test this group by operation and all the rest of it in isolation, if necessary. So I want to check some properties, like the number of astronauts is greater than or equal to 0. The spacecraft names are not blank. Now, that's actually testing also on the gateway. Now, this is testing the gateway, and this is an integration test, okay? Actually, this is testing the service with the real gateway. See, I instantiate the gateway and plug it right in, call it, get back the result, and check that there's an assert. Oh, I see. This is what I was saying before. I like to use AssertJ with the JUnit assert all. Even though they have soft assertions, this looks really intuitive to me. I don't have any problem with this. And you can mix and match without any problem at all. So assert that, and that's how AssertJ works. Everything's an assert that, and you put in the object you want to make assertions about, and then they have, oh, I don't know, 10 to 20 billion different assertions you could use. I mean, AssertJ is probably the most extreme example of syntactic sugar I've ever seen. I mean, it doesn't change any of the underlying behavior, but they've got methods for everything, and they're really great. So I say assert that the number now is greater than 0. I change that now. I make it is positive or 0. There's a question. Am I going to save this? Oh, the stream is, if you're talking about the conference, they are in fact recording all of these things, and they will be available. In fact, the YouTube channel for yesterday's already has the recording for. I mean, the YouTube channel already has yesterday's recording on it. So I think they're also going to break them up individually as well. At any rate, so I'm asserting that the number of astronauts is positive or 0, and that the craft name is not blank. I mean, that's another nice one too. Now, here's where you're going to start to need mocks. What if something goes wrong? What if the network's not available, or I coded the networking library incorrectly, because I don't necessarily know all the details of all the different libraries, or the parsing of JSON into objects fails, or the thing I actually was trying to check for, the grouping by operation, maybe I did that wrong. How do we isolate the problem? Well, this is where we need mocks and stubs. The service, we want to test that and the gateway in isolation. We have to test the gateway too, but I want to test that the service is, its functionality works independent of the gateway. So with the gateway, I've got a networking library inside of Java or a third party and a standard parser. This one I would do an integration test. So in case we don't quite get to the end slide here, the Mockito team emphasizes you do not mock what you do not own. Okay? If you have something that's using a library from a third party, then use the library. Don't try to mock a third party library, because if you do it successfully, then a couple things could go wrong. Like, first of all, the library may change and you won't even know. And secondly, it may be that if you have to mock one class in the library, that'll mean, oh, you also have to mock this, this, and this, and then that, and that. It winds up being a huge operation to mock the interface to a library. No, just do an integration test with the library. They mock the classes that you own, because those are going to be tested separately anyway. So here is my gateway test. This is a full-scale integration test. I just say get the response and check that the number is greater than or equal to 0 and the people.size matches the number. This is just straight JUnit. I'm not even using AssertJ for those. Nice and simple, but do it in an assert all. I'm only making this call once. Might as well check both features. Now, let me move on. Here's the service one. Now, what some people say is don't use a tool like Mockito, write the mock yourself, which you can do, but there's issues. So first of all, we could either write the gateway ourselves, or we could let Mockito generate it. Here's a mock I wrote myself. This is an Astro response with 7 astronauts. It's got assignments with an astronaut and a craft. And by the way, there's an Easter egg in here. The Easter egg is that the actor who played Will Robinson on Lost in Space back in the 60s is the same actor, Billy Mooney, who played Lanier on Babylon 5 in the 90s. See, that's why you come to these things. How else would you know that, right? And by the way, Ellen Ripley really shouldn't land on the Nostromo on LV 426. That's just nothing good's going to come of that. Just thought I'd mention it. But you see, I made my own object here. So now I can go, okay, I'll instantiate my own mock gateway, and I do my assertions and check that everything's fine. But first of all, if the interface had more than one method, I'd have to implement them all, even if I'm not calling them. That's just a Java thing. If all the methods are there, you got to implement them. Also, how am I going to test the failure modes? I'm going to have to either put in giant if statements to say, oh, if I want this failure, do return this mock. If I want that failure, return that mock. Or I'm going to have to build like several mocks and somehow figure out which one to use. And any code I write, I have to maintain. Okay, I've got to update if the API changes. And the other thing, which is a bit more subtle, is there's no way to check the interaction between the class I'm testing and the mocks, the ones that are under the hood. In Mockito, I can say, did the methods in the mocks get called the right number of times in the right order with the right arguments? That happens automatically. Otherwise, I'd have to write it myself, and that's not so easy. Java doesn't record that automatically. You'd have to put in counters and things. So with the mock gateway, whether we do it ourselves or not, we have to create the mock. We set the expectations on it. When I call this with these arguments, here's what I want back. inject it into the class we're testing, check the results. Remember, we're not testing the mock, we're testing our class. And then the last part is verifying the interactions, and that's the difference between a mock and a stub. You see, a stub, according to Martin Fowler, the old blog post he put up, mocks aren't stubs, it's classic, just Google it. Stubs, I think I have it right here. Yeah, let me show you the test first, and then I'll get to the documentation. So here, step by step, I'll create a mock. Now, this is the old style way with the method. I'll get to the annotations in a minute. This is setting the expectations. When I call get response on the mock, return that rigged object I made. And then plug it into the object I'm actually testing, do my test, and then the verify part is I verify that the get response method was called on the mock gateway exactly once. That's what I want. And that takes care of it all. Now, there's some questions about how is Mockito different from other mocking libraries like PowerMock or JMock, or there's a whole series of them. I'm going to say there are differences. I don't want to get into that now. I'll simply say that Mockito's built into Spring, and it's by far the dominant one used in the industry. The others are fine, nothing against them, but I figured I'd learn the one that was the one that's most common, and the concepts I'm describing work on all of them. It's just the details that change and a couple of the edge conditions. Mockito a few years ago didn't have a lot of the capabilities that PowerMock had. But now with Mockito, you can mock final methods, you can mock static methods, you can mock constructors, all these things that you didn't used to be able to do, you can do now. Okay, so now what's the difference between a mock and a stub? Just to point that out. Yeah, somebody pointed out, PowerMock was used when you had to mock static methods, but now you can do that with Mockito. That doesn't mean you have to, just it's available. The difference is a stub stands in for the dependency and gives you specific responses to method calls. When I call this method with these arguments, here's what I want back. And that's it. You set the expectations. You don't write tests for that. However, a mock is exactly the same, except you verify it. You check that the methods from the object I'm testing called methods in the stubs the right number of times in the right order with the right arguments. You verify a mock. And here's the interesting part. The generated class is identical either way. It's a mock object. And the only difference as to whether it's a mock or a stub is whether I verified it or not. This is something that's just not real obvious from the documentation. But that's why people get sloppy about whether to call it a mock or a stub. It's the same class. It's just whether you verified it. Yeah, so they're often used interchangeably. Mocks verify what they call the protocol, the interaction between the class we're testing and the mock itself. Okay, now let me show you in my Mockito one here, not that one, this one. Okay, so there's my Astro service test. I shifted to the Cerritos, by the way. I like lower decks, by the way. So there's my mock object. And here I can, I could say, when I call get response on the gateway, return that mock object. And then here, this is the method I'm testing. Check that the map entries are right. And this is why I like tools like AssertJ. You see, in regular JUnit, there's nothing special on how to test a map. But in AssertJ, I could say assert that the map contains entry, and there's other convenience methods as well. I think I'm only using contains entry in this one, but they're all there. And you see how that easy that is to write. Now, the other part that this one's using, let me scroll up to the top here, is I'm using the annotation support. I'm saying, hey, Mockito, create a mock of this guy and inject that mock into this class, and this is the class I'm testing. So that in the tests in this class, you don't see me instantiating the class, you don't see me creating the mock and plugging it all in. I can just say @mock and inject mocks, and that works because I'm using the Mockito extension in JUnit 5. So that works here. But here's another neat thing. I can test for failures just by changing the expectations. I can say, hey, when I call the get response on the gateway, then throw an IO exception, which is a runtime exception. Just throw that. So now I can use JUnit's assert throws to say when I call this, I get a runtime exception. Then I can get the cause, and I could check that the cause is an IO exception in the message. Or a lot cleaner in AssertJ. Look at this. This is a thing of beauty. Assert that exception of type runtime exception is thrown by this executable with cause exactly instance of IO exception with message containing network problems. I mean, that's gorgeous. I mean, this isn't bad. The one above it, that's fine for JUnit. But look how clean that is. I can read it out loud and you know exactly what it's doing. And now I've tested a failure method. Here's the same thing using the BDD assertions instead of the regular ones. And I love this thing like that. And I think that's everything I wanted to show you in that one. Yeah, so I've got it with a mock. I have it with my own mock. I got all these. Here's another AssertJ method. Contains only keys, for example, or contains entry. There was also contains methods, which are in order, or contains in any order, which isn't. And you can do that with arrays too, not just lists, and on like that. Okay, let me go back here. Now, let me say something about spies, because spies tend to get overlooked in a lot of this stuff. The thing about a spy is they can be dangerous and they can be really helpful. A spy usually is used to mock an existing class, something that's already in your system that you do not want to modify, like a library class, for example. And method calls will pass through the spy to the underlying real object. Now, the dangerous part is you can set expectations on some of the methods. You could say, hey, when I call this, here's what I want back. That's dangerous because you could make the object be in an inconsistent state. But if we don't want to do that, say all we want to do is wrap the object, this is how you can test a logger, for example. And I have an example here, and this was also, I made a little YouTube short about this, but I'm going to show you the code. So what I had here, let's see. Oh, no, that's not it. It's the logger one. Where's my spy? Oh, it's in a different repository. I thought I had it in here. Let me just explain then, because it's not complicated. And the idea is that I had a client asking to check that their logger was working correctly, and they were getting lost in how do I capture the log output? How do I go and get the console or the file that everything's being logged to, and what happens if it's multi-threaded, and how do I handle all that stuff? And I did try to figure out how to do this in capturing the output. And it finally dawned on me, no, that's the wrong way to go about the problem. I don't need to test the logger. That's the job of the people who wrote the logger, the logging library. I'm not trying to verify their work. What I need to do is wrap a spy around the logger. And then when I call the method that as part of its job does some logging, just verify that the logger method was called. Verify that we called info or debug with the right string, with the right arguments, whatever the arguments happen to be, the right number of times. And that's good enough. I mean, it verified that the logging happened without me having to go into the depths of figuring out how to test a logger, which is already tested by the people who wrote the logger. You know what I mean? I didn't do any of that code. I'm just testing, did my code call the logger at the right time? Spies are perfect for that. And I just don't happen to have that GitHub repository open. I don't want to take the time now. But it's a really nice demo of when you could use things like loggers and test them. Okay, now a couple of additional notes just for your information. Mockito is probably the library with the least changes per major version. I mean, Java, in several of the Java major version changes, there were maybe one or at most two major features and a bunch of smaller stuff under the hood. Like in Java 11, the big release feature was the HTTP client. Java 15 had the text blocks. Records are in 16. 17 had a bunch of stuff. 21 has a bunch of stuff. Mockito 2 really did refactor Mockito 1. You can't just reuse Mockito 1 code. You have to write Mockito 2. The only change from Mockito 2 to Mockito 3 is that it required Java 8 or above. That was it. That was the only change. Mockito 4 took all the things that were deprecated in terms of methods and classes from Mockito 3 and just removed them. So again, if you didn't use anything deprecated, you're good, you're fine. And Mockito 5 just said, we're going to bump the minimum JDK up to Java 11, And they did one interesting thing. They included this thing called an inline mock maker. And what that is, that's the thing that lets you test static methods and final methods and constructors. Prior to that, in Mockito 4, you needed a separate dependency. In Mockito 5, you don't. It's all in the core now. There was a question that mentioned argument captor. And I don't tend to use it very often, but it is quite helpful. Instead, what I use all the time is, let me move on here. I'm not seeing, oh yeah, I've already shown you all that. Okay, let me skip all that. Is argument matchers. These are really useful. Argument captors, for those who are not aware, capture the input argument that you actually used when the test class called a method in the mock. Usually I'm supplying the argument, so I don't really need to find out, yeah, is that in fact what was used? But if the argument I gave was changed in some way by my test class and then use that to call the mock method, then I can capture it if I want and make sure it's what I thought it was. But these happen all the time. Instead of saying list, when I call the get of 0 on a list and return 42, I can say when I call get on a list with any int, then return 42. Now, side point here, I took this out of the Mockito documentation, and even they say do not mock a list. Okay. Use a real list, but it's one of their examples. You can spy on a list, however. Spy on a list to make sure that the get methods were called with the right values or something like that. There's an equal one. This is a little trap that comes up with the argument captors. If you try to verify a mock or set up expectation with any of the arguments as these argument matchers, then they all have to be argument matchers. So here's an any int, here's an any string. This is a hard-coded string. That will not work. You have to use an equal in order to make them all argument matchers. That's what that's for. There's a comment about sealed classes in those as well, and I have used sealed classes with Mockito without a problem. The only issue will come up is because again, the data type is the same. So if you're using a sealed interface, for example, I tend to use a lot. A sealed interface says I'm permitting the following classes to implement it, and then the mock is still returning a wrapper around that same type. So Mockito will go, yeah, it's okay. I mean, in Java, we'll say, yeah, it is the right type. So it shouldn't be an issue at all. So I don't expect any problem with that. Okay, you can also make custom matchers, which can use a lambda expression. There's an argThat method that says a list of size 2, for example. This was one of those cases where they got lucky. It's like, you notice before Java 8 came out, there were lots of libraries that had interfaces with only a single abstract method. All of those interfaces magically became functional interfaces as soon as we had lambdas in Java. And this was one. The examples in the Mockito documentation of how to make a custom argument matcher usually involved an anonymous inner class implementing this. Well, now this is a lambda that matches that structure, right? Takes an argument, returns a Boolean, we're good. The only thing I have to warn you about with argThat is if you do that with primitives, you'll get a weird looking error that doesn't seem to make any sense. The solution is just use int that, long that, double that, whatever the primitive type is, and you're good. So if you get a weird auto unboxing caveat error, just switch to those. And these are all in the book, by the way. Okay, methods that return void, you have to reverse it and say do throw or do return or do answer. You have to write it the other order, just for reasons, I'm going to skip the business about answers, although I really like it. Ordering uses an in-order mechanism. And now you can do final types, enums, final methods. It used to be a complicated process. Now it's just built right in 5.x, So about that Astro Gateway, again, the integration test is fine on that one. We're not going to mock the library or anything like that. And there are these limitations are now gone. Like you couldn't mock static methods until Mockito 3.4 or constructors till 3.5. You still cannot mock equals and hash code. You also can't mock private methods because they're like, why are you calling private methods? Remember, you're not testing the mock. You're testing your own class. Is your class calling private methods in the mock? Why? So no, they're not doing that. That's a design issue. But you can mock classes, interfaces, everything. A couple of quick slides on AssertJ, like there's the syntactic sugar, here's the documentation, And I think that's all I'll say. Just wrap everything and assert that. One IntellIJ thing, I went into editor general auto import, and there used to be a way where you could say which class, which static import you favored. I couldn't find that anymore, so I excluded the ones I didn't want. So that was in editor general auto import, and I added these to exclude from auto import so that when I put in an assert that and hit control space, it knows what it should be. The only one I want is the one that's left. So that I did say something about JetBrains. So let me just skip up to here and say, JUnit 5, I really like it. I think that the developers have done a wonderful job rewriting something we all used. Mockito does exactly what it was designed to do. It's the key there is to understand what it's designed to do. And AssertJ, I use it more and more all the time because I keep finding things I didn't know about that are great. And of course, IntellIJ IDEA is wonderful. It's the best. So there's the links to the channel. If there's any time for questions, I'm more than happy to hang out. I do admire the endurance of everybody still here. I mean, it's been a long 2 days, but thank you so much. Mala, did you want to say anything at the end? I think you're muted again, Mala.
My God. That's the fourth time today. That amazing presentation. And I just wanted to bring up a beautiful comment. So this is amazing explanation of when to use mocks. And you would love this one.
Oh, geez. Okay. Well, I'm definitely showing that to Venkat. So yeah, thank you.
There's specifically one for you and Venkat. So.
Yeah. Oh, well, you didn't see at another conference, they mentioned one of my talks at a conference coming up, and they put Venkat's picture on it.
Wow. Wow.
I just feel like we're linked. It's just destiny. It's meant to be.
So. Yes. So this is another comment. And so this was a question, but before I take that, you have folks who want to give AssertJ a try now. So that is great. Just one
here's the
question
docs.
that I want to take.
Oh, you're not sharing my screen anymore, are you?
Let me add.
There you go. This is the AssertJ documentation. It's assertj.github.io. It's a GitHub IO project. And from here, you could find out everything you need to know. I have not found anything it couldn't do that I wanted to do. So I've been very happy with it. Does Mockito support stateless functions? As far as I know, I haven't seen anything restricting those. In fact, I think it probably works better on those than stateful ones. So yeah. Oh, I have a stateless service joke. I never told you that. Yeah. I say to my friend, I think all services should be stateless. And he goes, really? Why do you think that? And then I say, why do I think what? Wait. I got it here.
That's a good one. That was a good one.
Yeah. Okay. So at any rate, I had to bring that up just for your information.
And that was amazing. And with that, thank you so much. I think you've already answered all the questions because you were answering the questions as you were going along with your session. Once again,
feel free to keep in touch. My email address is there, and it'll be on the contact information. Feel free to send any questions I didn't get to. Thank you, Mala.
Thank you so much. A pleasure to learn from you today. Thank you so much, Ken. Bye. And now let me bring our other host. Hey, Marco.
Hello. Hey, Mala.
Hey.
So that was a long day.
It was a long day.
Yes, lots of learning. Before we talk about anything, let us bring the slide which talks about the sharing of feedback on this conference. Yes, let me find. Yes, here we have. That's amazing, Marco. So everyone watching, if you could scan the code and share your feedback, that would be great. It would really help us to improve the events that we plan in future. And we would love to hear what you think about the current event. And with that, should we bring up the Mentimeter?
Yeah, bring a Mentimeter. Come on, let's finish with some fun.
Let's have some fun.
And
we have some fun in Kotlin, because everything in Kotlin is fun. Sorry, that's my obligatory programming joke.
Right, and everyone watching, if you've already scanned the code, so you can use the same QR code